Hi, welcome to the course Using HBase for Real-Time Access to Your Big Data. Introduction to HBase. After completing this lesson, you should be able to explain what NoSQL databases are and understand the purpose of HBase, explain how HBase fits into the CAP theorem, explain how HBase adheres to the ACID properties, compare and contrast HBase and relational database management systems, understand the roles of HBase components and how everything fits together. Describe the characteristics of HBase tables. Be able to list the new features of the HBase .96 release, and also see how to use HBase shell commands for basic tasks. What is HBase? HBase is essentially the database that is modeled after Google's Bigtable technology. If you have some familiarity with Bigtable, you already understand that HBase is a sparse, distributed, persistent, multidimensional sorted map. Let's take a minute to figure out what we just read there. Sparse basically means that the data is scattered. Distributed means that the storage of the data is spread out across the different hardware. Persistent means that the data will be saved. Multidimensional means that for a particular cell, there can be multiple versions of it. Sorted map basically means that to obtain each value, you must provide some sort of key. You use HBase for random, real-time read-write access to your big data. HBase is an open-source technology that is embraced and supported by IBM. Many companies such as Facebook and Twitter also uses and embraces HBase. HBase and its native API are both written in Java, but you can practically use any of the popular and common programming languages to work with HBase. So HBase is a NoSQL technology. NoSQL basically means not only SQL. We need to understand that HBase is not intended to replace RDBMS. HBase is designed for specific business needs, and we will get into what those are later in the lesson. A traditional RDBMS are not very scalable when the data reaches the terabytes and the petabytes realm. Sharding occurs way too often, and when the data volume goes up too high, it just becomes very inefficient. It becomes difficult to keep the referential integrity between the tables, the joins becomes too complex, and rebalancing becomes very resource intensive. NoSQL technology alleviates these issues and provides a cost-effective way to use commodity hardware in the cluster. NoSQL technology supports a very flexible data model, and this is perfect for big data because when your data comes in from various sources such as tweets or messages from Facebook, the data types are not always known. The CAP theorem. So what exactly is the CAP theorem? Basically, CAP theorem states that a distributed system can only guarantee two of the three CAP properties. So let's go over what these properties are. Consistency. All clients see the same data at the same time. Availability. A guarantee that every request will see a response, whether it is a success or a failure. Partition tolerance means that the system will continue to function when a node fails. A distributed system, again, can only guarantee two of the three properties. HBase is considered eventually consistent, and it implements consistency and partition tolerance. For example, if we have a region server failure, that is recoverable, however, the data will be unavailable for a period of time. ACID properties. The HBase is actually considered a non-ACID compliant database, but we'll see here how HBase does adhere to specific properties. The A stands for atomicity, where an operation is considered atomic if it either completes entirely or not at all. HBase, in this case, provides row-level atomicity. Consistency and isolation. All the rows returned from a request will be a complete row that existed at some point in time. So certain requests may yield one result from one client, while another request from a different client may yield something entirely different based on the time. Scans are not consistent in this case because it will only return a version of the row at one point in time. Durability. Durability means that any updates will not be lost, and HBase has this property. More information can be found on the Apache websites regarding the ACID properties. Why HBase? Up until this point, you have seen some of the background information on HBase. You have a basic idea of what HBase is, but why HBase? What makes HBase so different and unique where you would want to use it. Well, first of all, Apache Hadoop includes HBase, so when you're dealing with big data, it comes in really handy. You should understand that HBase can replace costly implementation of relational database for big data applications. It enables horizontal scaling for very large datasets, and it also supports flexible data models of sparse records. If you need something that can give you quick, random read writes to your data, HBase is your tool. And as opposed to relational databases, HBase provides automatic sharding. I want to emphasize a few things that you need to keep in mind when thinking about using HBase. HBase is not designed to replace your traditional RDBMS. It does not support SQL, it is not for transactional processing, and it does not support table joins. You only want to use HBase when you need specific feature sets, such as the one we mentioned before. You definitely don't want to use HBase as a general all-purpose database either. Keep in mind that HBase stores everything in an array of bytes, and this allows us for a very flexible data type model. You have reached the end of this video. Please proceed to the next video to continue with the lesson.